So in this tutorial we're going to look at factorizing quadratics. And what does factorizing actually mean? Well, here I've laid out some algebra tiles, and we can, let's just change these to negatives actually. What we can do is just write out what these represent. So we've got 4x squared, this is the large area here, 4x squared. We've got 8x's, subtract 6x's, so we've got plus 2x minus those 12 ones there, so that's minus 12. And we've got one of the sides. So laid out here we've got 2x minus 3. So the missing side here would be our answer if we were thinking about this as a division. So we've got 2x minus 3 dividing into 4x squared plus 2x minus 12 would give us, well, we can see the missing length is 2x plus 4. So of course another way of writing this or saying this would be 2x minus 3 times 2x plus 4 would give us 4x squared plus 2x minus 12. And what we're going to do in this tutorial is look at precisely that problem. If I had just this central area here, so 4x squared plus 2x minus 12, and I didn't have any sides, could I still get these factor pairs? Could I still get, let's do the brackets there, 2x minus 3, which we've been given here. Well, let's get rid of it. There we go. Okay, 2x minus 3 times 2x plus 4. If we didn't have these things, let's erase all of this now. Could we find not just one side, but this time two of those sides, the pair of factors that multiply together would give us 4x squared plus 2x minus 12. Okay, so let's get rid of this and just work with this expression. Now the very first thing that we need to find out is whether or not this is factorable in the first place, because a lot of these quadratic expressions are what we call prime. They won't break down any further into factor pairs, and so we may be told that this is factorable, we may be instructed to factorize it, but if we're not, we need to look at it and say, well, is it factorable in the first place? Now, to answer that question, there are several ways of answering it, in fact. The first, I think, is probably the most complicated, so you might want to skip this part of the video, but what we're going to use is something called the quadratic formula. Now, the quadratic formula looks like this. Minus b, so x is minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is this first coefficient here, 4 in this case. B is the second one, so this will be 2 here, and C, we need to be careful here, means this third term here, the number at the end, which isn't 12, it's negative 12. So that's what the quadratic formula means, and a lot of students memorize that. You need to memorize it if you're going to pass certain exams. But at the moment, all we need is a little tool which is part of the quadratic formula. So I'm just showing the quadratic formula so you know where it comes from. And if I get rid of the other bits that we don't need, all we are left with is something called the discriminant. So the discriminant is this part that was underneath that square root sign in the formula, b squared minus 4ac. And the discriminant, it turns out, is an extremely useful thing to learn and to use for various purposes. Okay, so how do we use it to find out whether this is factorable? How do we use this? Well, the first thing we need to do is plug in our numbers. So we've got 2 for b, so b squared is going to be, well, 4. 2 times 2, 4. And now we've got 4 times a, which is 4, times c, which is minus 12. If we work this out, we've got 4 subtract Well, I'm going to just change this around a bit to make it easier so that we don't have to reach for a calculator or strain ourselves at all. So it's going to be minus 4 times minus 12 if I commute it. So that would be plus 48 times 4, which is going to be 4 plus 192, giving us 196. Now, if I remember the quadratic formula, the idea of the discriminant being under a square root sign, like that. So originally the discriminant was under that square root sign. If the number I get under here isn't a square number, perfect square number, then I'm going to get a fraction, or I'm going to get something, I'm not going to get a whole number, an integer. So the reason I've done this is just to check that this number is indeed going to give me a whole number when it's square rooted. So in other words, this needs to be a square number. Okay? And 196 is a square number. You probably recognize it. It's the square of 14. And that means that if 14 squared is 196, if this is a square number, then this is definitely going to be factorable. So I can say 4x squared plus 2x minus 12 is factorable. Well, we knew that anyway, okay, but I wanted to just show you how we work that out if we didn't know that. So let's try it, in fact, with some equations that we don't know. So let's try 3x squared minus 2x minus 8, and we need to know whether that is factorable or not. So again, I think I'll do this here. We use b squared, so that's minus 2 times minus 2 is going to be 4. B squared minus 4 times a times c. So 3 times negative 8. So there we go. And we've got 4 minus, well, how would we do this? Let's again do the commuting again. So we've got 4 eighths, so plus 4 eighths, so we've got 32 times 3 is going to give us, let's put our equal sign in here, 4 plus 96 equals 100, and 100, of course, is the square of 10, so it's definitely factorable. So 3x squared minus 2x minus 8 is factorable. Okay, let's try one more. Let's try 4x squared plus 8x plus 3. Is that factorable? Well, again, we reach for our discriminant. We say, we can even do this mentally. So we've got b squared is 8 times 8, so that's 64. And now we subtract 4 times 4 times 3. So we've got, let's write it down. We've got 64 minus 4 times 4 times 3, 12. Okay? And so now we've got 64, subtract 48, which is going to give us 16. And 16, again, is a square number. And if it's a square number, or 0, then the expression is factorable. So it's a handy little way of checking whether a quadratic is factorable. Okay, let's erase that and actually factorize it now. So let's just, yeah, actually let's bring back the quadratic formula there. Okay, so we're going to use the quadratic formula now to factorize those expressions that we haven't worked on yet. So let's start with 3x squared minus 2x minus 8. And again, I would say that this isn't the easiest way of working, but just to show you that the quadratic formula can be used in this way, I'm going to work this out and then try an alternative method. So 3x squared minus 2x minus 8, we've already worked out is factorable, so now we just need to plug in the numbers into the quadratic expression. So we have minus b. Well, b is minus 2. So minus b is going to be minus 2. And then we've got this plus or minus. Plus or minus. That's because when we square root something, we tend to get two answers. So plus or minus. And then we've got the discriminant under here, and we already worked out that the discriminant of this was 100. So if we square root 100, we get 10. Okay. Now we divide by 2 times a. Well, a is 3, so 2 times a is 6. And if we work this out, we've got 2 plus or minus 10. So 2 plus 10 over 6, or 2 minus 10 divided by 6. And that's going to give us, well, 2 plus 10 is 12, divided by 6 is 2, or we've got 2 minus 10, so that's minus 8 over 6, which is negative 4/3. Okay, now we haven't quite got our factors here. What we've got is two values for x. X can be 2 or x can be negative 3. And the way we turn this into factors is something that we'll look at in a little bit more detail, is we reverse the signs. You'll understand why we do this and how this works later on. But we reverse the signs to get, first of all, x minus 2, and then the second factor is going to be 3x, so we take that denominator there and turn it into a multiplier for the x, 3x plus 4. And that is the sort of algebraic or formulaic, if you like, way of figuring out how to factorize an expression like this. A lot of people know how to do that. They memorize this. They don't know quite why it works, but they know it does work, and so they use it. And the final operation that we should do always when we do a factorization like this is we should multiply out again and make sure that the original expression is what we actually get. So x times 3x, 3x squared. Okay, x times 4 is 4x. Minus 6x is going to give us our minus 2x, and then minus 2 times 4 gives us our minus 8. So this is correct. It works. Let's try it again with another one just to show you how it works again. So let's erase these. Okay. Let's try the other term that we had. So we had 4x squared, 4x squared plus 8x plus 3. And we've already decided that this is definitely factorizable. I think we found that it was 16 was the discriminant. Okay, and we can just check that. B squared minus 4ac equals 16. So now what we can do is we can use the whole of the quadratic formula, just as we did before. So we start with b. So it's minus b gives us minus 8, plus or minus the square root of the discriminant. So the discriminant was 16, so the square root of the discriminant is 4. So plus or minus 4. Divide by 2 times 4, which is 8. It gives us negative 12 divided by 8, or minus 4 divided by 8. And that means that our factors must be, well, here we have two terms which can simplify, so let's just simplify it first. So we've got minus 3 over 2, or minus half. So we take that 2 and say, well, that's our 2x. We reverse the sign, we say it's plus 3, and here we've got 2x again, plus 1. 2x plus 3 times 2x plus 1. Multiply them out, 4x squared. So 2x times 2x gives us our 4x squared. And we've got 2x plus 6x gives us 8x. And then finally we've got 3 times 1 gives us 3. So those are two examples for us to look at, which are using this method. First of all, of factorizing, using the discriminant rather, to find out whether it's factorable or not, and then using the whole of the quadratic formula to get these answers, which are then converted into the factor pairs. And if that sounds complicated, I agree with you. I think that is complicated, and there's a much more straightforward way of working it out. So that's what we're going to look at next. Right, so let's just erase this discriminant and look at, I think we could easily say a better way or an easier way, a simpler way of working these things out. So let's use the same quadratic expressions, and then we can compare them to what we just did with the quadratic formula. So the first thing we're going to do is write out our problem. So we've got 3x squared minus 2x minus 8. Whoops, minus 8. And this time I'm going to do something, I could simply, let's just show you this to start with. I could simply try and work it out using deductive reasoning. So I could say, well, I've got to make x, I've got to make 3x squared, and the only way I'm going to do that is by having 3x here and x here. So I could start like that, and then I could try and make my middle term, I know, is going to be 2 terms combined together, and I could work it out maybe doing it that way. But I like to be a bit more systematic than that without being totally algorithmic. So let's show you how that can be done. All right, so let's go over to one side here and think about the problem. I have got to somehow find out what this middle term is made up of. Okay, it's going to be something like 6x minus 8x. Anyway, it's going to have 2 pairs, and sum together, in other words, added together, they're going to give me negative 2x. So what could that be? Well, if I just arrange this like this, I'm going to think first of all of this product, in other words, this first term, the A term here, multiplied by the C term. So I've got 24, 3 times 8 is 24, and at the same time I've got to have these terms add together to make negative 2. Now you'll see how this works out in a moment, but I'm just writing these down to start with. This one's called the product then, and this one is the, let's do a little arrow there, this one is the sum, and sometimes this is called the sum and product, or the product and sum method. We can arrange this how we want. Some people use a diamond. I'm going to use a cross just to give me a little space to work in. And we're going to work on the product first, and then we're going to think about what we get, whether it's going to work with our sum. So we start with 24 and say, well, what are the factors of 24? We've got 1 and 24, but these aren't going to combine together to get me minus 2. I've got 2 and 12, but again, the difference between 2 and 12, nowhere near 2. 3 then, and 3 times 8 is 24, so 3 and 8. We're getting closer, 3 and 8, but the difference there is 5, so that's no good. Here we are, 4 and 6. Okay, now 4 and 6, the difference is 2. Well, our product actually is 3 times minus 8, so it's negative 24. And so 4 times negative 6 will give me minus 2. In other words, 4x minus 6x are the 2 pairs that we're working with. So this will split into 4x subtract 6x, or negative 6x plus 4x. But that's how that middle term splits. Okay? Now, knowing this means I can easily factorize this problem. I'm going to use grid method. because that works very nicely as we've seen. So let's put it here. Let's draw a grid. Okay. Let's make that a bit nicer. Okay. All right. There we go. And a grid, as we've seen in the other videos, gives me 4 boxes. That's why it's called a quadratic expression. That's where the term quadratic comes from. So it gives me a grid of 4 boxes, an area if you like. And the first box is obviously going to have the 3x squared in it. So we know that we're going to have 2 terms here multiplied together to get 3x squared. We also know that last box is going to be -8, so we can fill that in if we like. And we now know that these boxes are going to be -6x, which we'll put there, and +4x. Okay. So now we've got our area filled in. Okay. Let's just rub this out because we don't need this anymore. Okay. Now all we've got to do is work out the sides. And it's pretty straightforward. The 3x squared, well, we know that one of the sides has got to be 3x and the other's got to be 8. So we need the 3x to run along here, I think, because we've got a 6 there, which is a multiple of 3. So we're going to have the 3x here, and we'll have the x there. And then just check, 3x times x gives us 3x squared. So we seem to have it correct so far. And then we just work out the rest. 4x, well, 4x divided by x will give us +4. And just checking, 4 times x gives us 4x. So that one's correct. -6x, so -6x divided by 3x gives us -2. And again, checking, 3x times -2 gives us -6x. So we've got our answers. We've got one term must be x minus 2, and the other term, the other binomial I should say, 2 terms, is 3x plus 4. So our answer is x minus 2 times, what did we say, 3x plus 4. Okay, so that's the first one done. Now let's work on the second expression that we had. It was 4x squared plus 8x plus 3. And again, let's move over to one side then, and we've just got plus terms here, so it's all positive. So we don't have the complication with the minus terms here. But what we've got is 3 times 4, so we've got 12. Now I can already see there is going to be a little interesting complication here, but we'll come to that in a moment. So our product then is 12 and our sum is 8. So it's got to sum to 8x. It's going to multiply out to, it's 12 and 8, so 12 is the product, 8 is the sum. Okay, and we'll see how it all multiplies out in a moment. Now, we've got 12 then that we've got to break down. So our factors of 12 are 1 and 12, 2 and 6. And we're already there, in fact, because 2 and 6 will add together to give us 8. So we've got 2 and 6. In other words, 2x plus 6x is how this is going to break down. So we don't have to write this out, but it's going to be 2x plus 6x. So now we can work on our grid. Okay. Okay, giving us our 4 boxes, which we now know, there we go, which we now know all the values that have got to go in those 4 boxes. So we've got 4x squared, we've got 2x and 6x, so let's put the 6x here to see if that works out. If it doesn't work out, we can always swap things around, but where we put them seems to be quite important. And then we've got our plus 3 down the bottom here. So plus 3. Let's just write 3. Oh, let's put plus 3. Okay, so let's now try and work out how we would make 4x squared. Well, there seem to be two ways. There's 2x times 2x, which would give us 4x squared, or it could be 4x times x. Let's try 4x times x to start with. So we've got 4x there. And our x then must go there. 4x times, in other words, 2x divided by 4x would give us half. Now, I don't know if we want to have half, but we'll leave it there for the moment. It's not an integer. If we particularly wanted to have integers, then obviously that wouldn't be acceptable. But let's just work with it for the moment. So now what would this be? 6x divided by x will give us just 6. So we've got a pair of factors. Okay, so let's just rub this out. Equals 4x plus 6 times 2x plus x plus a half. Okay. But what would happen if we didn't actually want a half here? What if we worked it out with the 2x? Well, let's try it. Okay. So let's rub this out. I mean, the idea here is to have fun and to play around with numbers, with our values here, and see what happens. Okay. So now 4x squared is going to be divided into 2. Going to be split up into 2x times 2x. 2x, 6x divided by 2x, so 2x times something gives us 6x, that's going to be plus 3. Just checking, 3 times 2x gives us 6x, so that's correct. And here we've got 2x divided by 2x, so in other words it's just 1. So in fact that worked out rather nicely. So our answer, perhaps a slightly neater answer, we could say, is 2 factor pairs that just work out without any need for fractions. 2x plus 3 and 2x plus 1. Okay, well, the second part of the video we'll just have a look at a little bit of theory behind this, but hopefully that method has given you a way of factorizing anything you're given, really, working it out first by figuring out how the middle term is going to be split, and then once you've done that you should be able to use grid method just to sort out all the values and to get the final factor pairs. I hope that's helpful. Okay, now finally I've got an arrangement of algebra tiles here that I've been working with, trying to figure out whether a certain expression is factorable or not. So let's write it out. So we've got 3x squared. Those are our 3x squareds. And we've got a load of tiles here that are trying to make altogether 4x. Okay, so I tried different variations on this, but all the time I have to make them add to, I have to make 4x. So that's my sum. And my final term is negative 12. So negative 12. So I've got 3x squared plus 4x minus 12. And using algebra tiles, there doesn't seem to be any combination of those tiles that will form a rectangle. And if it can't form a rectangle, a rectangular area, then it's not factorable across the integers. Now clearly you can factorize any quadratic expression if you're going to accept, or almost any, but you can use fractions and so on, but over the integers, which is what we're looking at here, this isn't factorable. Okay, well, how would we prove that though if we weren't working with algebra tiles? And even algebra tiles are really not providing a proof here. Well, the idea is to use the discriminant. So let's try that. So the discriminant gives us a foolproof method. So we've got the discriminant is b squared minus 4ac. Okay, so now we just plug in our values. So b is 4, so b squared is 4 squared, which is 16. So we have 16 minus 4 times a equals 3, so times 3, and c is negative 12, like that. Let's work this out then. 16 minus 12 times minus 12, so plus 144, okay, gives us 16 plus 144, 160. And 160 is not a square number. Therefore, 3x squared plus 4x minus 12 is not factorable. Okay, so that's how we can use the discriminant. It works very well, but if we're unhappy with the quadratic formula and we just want to have a go at it and show that it doesn't work, then because our method is so reliable that we've been using, that's good enough, and just give it a go and see if it works. If it doesn't work, then it doesn't work because it was not factorable. So remember, what we're trying to do with the grid method that we were using is initially what we need to do is split this 4x into two terms. Okay, so is it possible to split this and also have these two terms, so we get the product from these two terms, but we also need to form from the same numbers this sum in the middle. So product and sum. Okay, let's try. So we start with 3 times 12, which is 36. And we need to make, well, it's negative 36, okay? But we need to make 4, so we put our 4 in the bottom here. We can use a cross, we don't have to, but it seems to be a good way of organizing things, so I'm just going to put an X there. And now we try and find the factors of negative 36. So 1 and negative 36 could be negative 1 and 36, but we only need one of them to be negative, so let's work with these. 2 and 18. Okay, now we're getting closer to 4, but obviously we're still a long way off. The difference between 18 and 2 is nowhere near 4. So now we try 3. So 36 divided by 3 is 12, so we're getting closer, but the difference here is still a long way off 4, so we're not there yet. Now we're getting closer though, so this might well work. Let's try. 4 and 9. We'll have negative 9. So now we've got very close to 4, yet we've got a difference of 5. So if we use their real values, we've got a difference of 5. So, sorry, they're absolute values. So we've got a difference of 5, which isn't getting us to 4. Now the next pair of factors that we've got is actually the square root of 36, 6 and 6. Okay, 36 is not divisible by 5, so that's not going to work. So 6 and negative 6 is the next one. And from there, we've run out of factors to use. So we know that, I think, well, I mean, you know, because we could go to 9 and so on, and 12, but none of these are going to get us near to 4. So by the time we've got down to here, to 6 and minus 6, somewhere between 4 and minus 4 is where we're going to get our solution. But remember, we're doing this over the integers. Over the integers. We only want integer values if we're going to say that this is factorable. And in that case, we can say from this diagram that 3x squared plus 4x minus 12 is not factorable without actually resorting to this perhaps more mathematical, provable method of using the discriminant.